Now we're at the third chi-squared test of chapter 26. This one is the chi-squared test of independence. Now here's the good news. It's exactly the same test as the test for homogeneity, except it serves a slightly different purpose. So we're going to have a two-way table, and since it's a two-way table, that means there are going to be two variables being analyzed. The purpose of the test for independence is simply to see whether or not the two variables should be considered. Back to where it all started. We're going to go back to the data related to the Titanic. Now, this would be our observed matrix. We've seen this data before. It cross-references the survival status of everybody on the Titanic with what type of passenger they were. Now, the null hypothesis is simply going to be that the two variables are independent, and you have to name the two variables in your HO and your HA. So our null hypothesis would be passenger type and survival status are independent, and the HA would be passenger type and survival status are not independent. Now, you can use the word related instead of independent, except it's a little bit tricky, because if you use the word related, it kind of sounds like they flip, because another way of saying that two things are independent, which would be the null hypothesis, you would say they are not related. So take your pick. If you want to use the word independent, here's the HO and the HA. If you want to use the word related, here are the HO and the HA. So when it comes to make a picture, well, here's the picture. I showed all four different types of passenger status. First class, second class, third class, and crew. And I divided each one of them up into the proportions of what proportion of each one lived alive and what proportion died. Now, we did this back in first semester, and we simply looked at it and we said, are the breakdowns in basically the same proportion? And if they were, we said the variables seemed to be independent. But if they were in noticeably different places, we said the variables appear to be not independent. Okay? It matters what type of passenger you were on the ship when it came to whether you lived or died. So there's the picture we're working with, and we're going to turn that into the chi-squared test of independence. We're going to do this one totally on the calculator. Now, step one is going to be enter the data into the calculator. So it is a matrix. So we have to go to the matrix, second matrix. We're going to put the observed data in matrix A. So go over and edit. We're always going to put the data in matrix A. The only thing is, the last one I did was a 4x2 matrix. Well, this one happens to be a 2x4. So we have to change the dimensions to be 2 by 4. And you'll notice when I changed the dimensions, the calculator reconfigured. And there's some data in some cells and there are zeros in others. It doesn't matter because we're just going to rewrite the data anyway. So in my 2 by 4 matrix, I'm going to put the data 202 and 118 and 178 and 212. That takes care of my alive row. Now my dead row, 123, 167, 528, 673. And don't forget to hit enter. Okay, we now have the observed matrix in matrix A. It's time to do the test. Stat, test, chi-squared test. All of this is right. The observed matrix is in A. We want them to put the expected matrix in matrix P, and now just hit calculate. And we're going to get some things that we need. For instance, the test statistic is 187.8. And the p-value is 1.83 times 10 to the negative 40th. So our conclusion, we're going to do a p-value conclusion. Since 1.83 times 10 to the negative 40th is less than 0.05, our alpha value, there is evidence to reject HO. It appears that passenger type and survival status are not independent. Or if you used the HO and the HA with the word related, then the HA would be they are related.